All right, so ready to dive deep into squeezing that top performance out of our .NET Core apps.
Always ready.
We're looking at this performance optimization in .NET Core, a comprehensive guide.
Comprehensive is right. This thing is packed.
Yeah, and it's all about making sure those apps are, snappy and responsive, that they can really handle whatever we throw at them.
Exactly. And, it's not just speed, right? It's that sweet spot, that balance between resources, making sure it can scale, and that it's, well, stable.
A well-oiled machine.
Yeah, like a well-tuned engine where every part works in perfect harmony.
I like that. So this guide breaks it down into like 6 key areas. There's I/O, memory management, then we got asynchronous programming, dependency injection, caching, and of course, database optimization. Let's just jump right in, maybe start with I/O. That always seems like a big bottleneck.
Oh, yeah, for sure. I mean, think about it like this. You're, say, fetching data from an API. Now, if you're using those synchronous operations, your app's kind of stuck, waiting for a response.
Twiddling its thumbs.
Right. But with that async await magic, you can have multiple requests firing off at the same time and then process those results as they come back. It's like having, a whole team of chefs in the kitchen instead of just one.
Okay, so instead of waiting for one dish to be totally finished, they're all cooking at the same time.
Exactly.
Hmm.
And the guide has this great example with file handling, using those async methods.
Yeah, I saw that.
Imagine, reading this huge file, right? Instead of waiting for the entire thing to load, you can process it chunk by chunk as they become available. And this also helps with the whole memory strain thing, kind of like, I don't know, packing groceries strategically into multiple bags instead of trying to carry everything in one go.
Smart. So that actually brings us to memory management, which I gotta admit, it's always been a bit of a head scratcher for me.
It can be tricky, yeah. So inefficient memory use, that's going to lead to a lot of garbage collection, and that hits performance hard. But .NET Core gives us tools like span and memory, so we can be a lot more, well, controlled with how we work with memory, avoiding all those unnecessary allocations.
So we're essentially trying to like reduce the amount of garbage our code creates.
Exactly.
What about this large object heap thing?
Yeah.
Was mentioned in the guide.
Ah, yes. So those big objects, those large arrays or strings, they all end up in this large object heap. And the thing is, this part of memory, it doesn't get cleaned up as often as the regular heap. So if you've got too many large objects, you can end up with something called fragmentation, which is kind of like having a bunch of big, oddly shaped boxes that don't fit together neatly.
I can visualize that.
Makes it harder for the system to find that free space, and that's going to slow things down.
That's a great analogy. Okay, so moving on, let's talk asynchronous programming. This always makes my brain do a little twist.
It's definitely a different way of thinking, but incredibly powerful once you get it. Remember our chef analogy. Well, instead of just one chef working sequentially, we now have a whole team all working in parallel. And this is super important when you're dealing with lots of requests, like in, say, a web app.
Right, right. And the guide highlights HTTP client with those asynchronous methods for making those web requests. It's kind of like having a dedicated team just for online orders, sending out multiple requests at once while the app's busy doing other things.
Exactly. And that leads us nicely into another crucial thing, dependency injection. Now, it's great for building those modular apps that are easy to maintain, but we've got to use it wisely if we want the best performance.
Yeah, I remember learning about the different service lifetimes. You've got like transient, scoped, and singleton, but I sometimes get a bit tripped up on which one to use.
Picking the right one is key, for sure. It's like, imagine you're hiring someone for a job, right? So transient services, think of them as freelancers, hired for a specific task, and once it's done, they're out of there. Scoped services, they're more like contractors, for a particular phase of a project. And then singleton services, those are like your permanent employees who are going to stick around for the long haul.
So if you just need something for a single operation, transient's the way to go. But if it's specific to a user's request, then you'd go with scoped.
You got it.
Yeah.
And then if you have a service that needs to be shared across the whole application, like database connections or config settings, then singleton's your best friend.
All right, that makes a lot more sense now. So let's move on to something that can really make a difference, and that's caching. Essentially, we're just storing that frequently accessed data in an easy-to-reach spot, right?
Exactly. Think of it like having your most used ingredients right there on the counter instead of having to dig through the pantry every time you need them. Saves a ton of time and effort.
Okay, so in .NET Core, what are the different ways we can cache data?
Well, there are two main approaches. We've got in-memory caching and distributed caching. So in-memory caching, it's like having that small pantry in your kitchen. It's super fast and efficient for data you need, often within the app itself. But if you have a ton of data, or you need to share the cache across multiple servers, then you need something bigger.
So in memory is for quick access within the app, and distributed is like having a giant warehouse accessible from anywhere.
You got it.
What kinds of tools are used for that distributed caching, though?
Well, a really popular choice is Redis. It's known for being like super fast and scalable. You can store tons of data and access it from multiple apps or servers.
Makes sense. Okay, and let's not forget database optimization, which often seems to get overlooked. It's kind of like having a really well-organized library. If you know where to find a book, you can grab it instantly.
You're exactly right. Asynchronous queries, those are absolutely crucial. You don't want your app just hanging around waiting for the database to respond. And then proper indexing, that's like having a super detailed table of contents, lets the database find what you need quickly without scanning everything.
And the guide also mentioned these database profiling tools, right, to help pinpoint any bottlenecks, like a detective for your database.
Exactly. They can tell you which queries are taking the longest, which tables are getting hit the most, and where you might want to add an index or two.
So speaking of real-world applications, the guide has this awesome case study of a high-traffic e-commerce application. Shows how putting all these optimization techniques together can really transform a sluggish website into like a lightning-fast shopping experience.
That's pretty amazing.
So it sounds like we've got a good overview of the key areas, like the fundamentals of performance optimization in .NET Core. But where do we go from here? How do we actually put all this knowledge into action?
Well, that's a great question, and that's exactly what we're going to be digging into in the next part of our deep dive. We'll be looking at specific coding patterns, different tools, and some strategies for putting these principles to work.
So we've laid all that groundwork, but now the question is, how do we actually put these optimization techniques into like real action? What can developers really do to make their .NET Core apps hum?
Well, I'd say a really good place to start is profiling. It's kind of like having a fitness tracker, but for your application. You can see how it's performing over time, spot areas that need work, and really track the impact of all those optimization efforts you're putting in.
So you're talking about using things like performance profilers and those application performance monitoring systems.
Exactly.
I've used those before, but sometimes it feels like a fire hose of data. It can be like overwhelming trying to figure out what it all means.
It's true, you do get a lot of information thrown at you, but the key is to zero in on those bottlenecks, the spots where your application is spending the most time or using up the most resources. And those profiling tools, they can really help you pinpoint, which methods are taking the longest, which resources are getting hammered, and even where you might have concurrency issues cropping up.
So instead of trying to optimize everything at once, we can really focus our efforts where they'll make the biggest difference.
Exactly, that's the idea.
That makes a lot of sense. But you mentioned concurrency issues there. What does that actually mean, like in the world of performance optimization?
Okay, so concurrency issues, they come up when you have multiple threads or processes trying to access the same resources at the same time. And this can lead to all kinds of nasty problems. You're talking deadlocks, race conditions, even data corruption, the whole 9 yards, like having, 5 chefs all try to use the same stove at the same time.
Chaos. Yeah, complete chaos.
All right, so how do we avoid those concurrency nightmares? Well, there are a few key techniques. One is to use proper synchronization mechanisms, things like locks or mutexes. Those make sure that only one thread can get to a shared resource at a time. Another is to use data structures that are designed to handle multiple threads accessing them at the same time. They're called thread-safe data structures, things like concurrent collections.
Okay, so synchronization is like having a traffic light to control access to a busy intersection, and thread-safe data structures are like having separate lanes for each thread so they don't crash into each other.
Exactly, that's a perfect analogy. And then there's another technique called immutable data. It means that once you create a data object, it can't be changed. So that eliminates the risk of race conditions because multiple threads can read the data without messing each other up.
That sounds really powerful, but isn't it hard to work with immutable data in .NET Core?
It used to be a bit more of a challenge, yeah. But with C#9, they introduced these things called records, and they've made it way easier. Records are basically lightweight classes, but they're designed to be immutable from the get-go.
So records are like pre-packaged, tamper-proof containers for your data.
Yeah, that's a great way to think about it.
I like that. And it seems like all that asynchronous programming we talked about earlier, that plays a big role in handling concurrency well too, right?
Absolutely. Asynchronous operations let you offload those long-running tasks to background threads. So that frees up the main thread to handle other requests coming in. This can make a huge difference in how responsive your app feels and how much it can handle, especially in web applications.
Speaking of web applications, are there any optimization tricks that are especially important in that area?
One that comes to mind is output caching. It's all about caching the generated HTML of a web page so that the next time someone requests that page, you can just serve it directly from the cache. No need to go through that whole page lifecycle again.
So it's like having a pre-rendered version of the page just ready to go.
You got it. Output caching can really take a load off your servers and improve those response times, especially for pages that don't change very often. Another important thing is to try and minimize how many HTTP requests your web application makes.
How do we do that?
Well, there are a few ways. You can combine multiple CSS or JavaScript files into one bigger file. That cuts down on the number of requests needed to download all those assets. You can also use things called CSS sprites, which combine a bunch of images into a single image file. That reduces the number of image requests.
So we're basically streamlining how the browser loads all those resources.
You got it. And there are a ton of other techniques for web app optimization, like using a content delivery network or CDN to distribute static content closer to your users.
Yeah.
You can also compress responses using gzip or Brotli and optimize image sizes. Lots of options.
Sounds like a whole world of possibilities for making those web apps run smoother. But I'm guessing these techniques can be used for other kinds of .NET Core applications too, right?
Oh, absolutely. Many of the core principles are universal. Optimizing those database queries, managing memory effectively, using asynchronous programming, and profiling your code. Those are all good practices no matter what you're building.
But I imagine there are specific things to consider depending on the type of application, right?
Oh, for sure. For instance, if you're working on a desktop application, you might want to focus more on how fast your UI renders and how to minimize the impact of operations that could block the user interface. And if you're building a microservices-based application, well, you've got to pay close attention to the overhead of communication between those services and make sure they're properly scaled.
So it seems like performance optimization is never really finished. There are always new challenges and techniques to learn for different types of applications. But one thing is clear, it's absolutely essential for building great software.
I couldn't agree more. Performance is a huge part of the user experience, and it can make or break your application. By investing time and effort in performance optimization, you're really investing in making your users happy and ensuring your product will be successful in the long run.
Great point. So what advice would you give to .NET Core developers who are just starting out with performance optimization? Where should they begin?
Well, the first thing I'd say is don't try to tackle everything at once. Start by using those profiling tools to figure out where your biggest bottlenecks are, and then focus your energy on those areas. Second, don't be afraid to try different things and see what works best. What's effective for one application might not be the best approach for another. And finally, remember that performance optimization is an ongoing thing. It never really stops. As your application grows and changes, you'll need to keep an eye on things and adjust your optimization strategies accordingly.
It's funny, how these performance optimization things, they kind of apply beyond just the code we write. It's like we're optimizing entire systems. Could be an application, a database, even how we work.
Yeah, that's what I find so interesting. It's like these concepts, they translate across different areas. Like, think about our brains, right? Super complex systems. If we optimize how we think, how we learn new things, even how we make decisions, well, that could lead to some serious personal performance boosts.
That makes me think of like speed reading or building those memory palaces. Maybe our next deep dive should be all about cognitive optimization.
I'm in. But for now, let's stick with .NET Core. So, to our listeners out there, you're now armed with all this knowledge about building high-performance apps. What are you going to create?
I love that challenge. And it reminds me of something we talked about earlier, about really understanding the why behind all these techniques. We can't just like blindly apply them. We got to know how they work, when to use them, the whole 9 yards.
Absolutely. It's about making smart choices, decisions based on what your app needs and how it's going to be used.
So for someone just starting out with .NET Core performance optimization, what would you say? Like, what are your top recommendations?
Start with the basics. Make sure you really understand how .NET Core handles memory, how the garbage collector does its thing, and the fundamentals of asynchronous programming.
Solid foundation. What about tools? Any favorites you'd recommend for .NET Core developers?
Oh, there are some great ones out there. For profiling, Visual Studio has its built-in profiler. That's a really good place to start. Gives you a ton of detail about how your app's performing and where those bottlenecks are hiding. Then for monitoring, there are things like Application Insights, which can give you like real-time performance data and send you alerts if things go wonky.
And we can't forget benchmarking tools, right? Those let you compare different optimization strategies and see how much impact your changes are actually making. Benchmark.net, that's a popular one in the .NET world.
Oh yeah, that's a good one. And it's important to remember this whole performance optimization thing, it's an iterative process. You make a change, you see what happens, then you tweak and refine based on the results. It's a cycle, constantly improving.
And the more experience you get under your belt, the better you become at just like sensing what works and what doesn't. You start seeing patterns and you can even anticipate potential performance issues before they even show up.
It becomes second nature. Like you automatically think about those performance implications as you're writing your code.
So as we wrap up this deep dive, I want to leave our listeners with one final kind of thought-provoking question. We've talked a lot about optimizing code, databases, even our own thinking. But what about optimizing the .NET Core runtime itself? What are the limits? How can we push it even further?
That's a great question. And it's something the .NET Core community is like actively working on. There are always efforts to improve how the runtime performs, make the garbage collector even better, and enhance those core libraries. And with every new .NET release, we see significant improvements in performance and efficiency.
It's exciting to see how the platform is evolving and how those advancements are enabling us to build even faster and more powerful applications.
It really is. And it shows just how important it is to stay current, to keep up with the latest and greatest in the .NET world.
Well, on that note, I think we've reached the end of our deep dive into .NET Core performance optimization. Hopefully you found it valuable. Remember, this whole performance thing, it's a journey, not a destination. Always more to learn, always new ways to improve. So keep experimenting, keep pushing those limits, and keep building amazing things. Thanks for joining us.